Morning, my dear students. Last session, we have seen the procedure to solve for the laterally loaded portal frames using portal method. And this session, we will see an example how we solve a frame applied by lateral loads using portal method. A step-by-step procedure that we have discussed in the last session. First, let us recall what was the procedure. So, this is the procedure which is discussed in the earlier session. The calculation of column shear first. The reason behind to start with column shear is explained because you have an assumption on column shear relation. Interior column shear will take the twice that of the exterior column shear. That's why we start calculating with column shear first, then the column end moments, and then beam end moments, and then beam shear, then column axial loads, right? So this is the flow of calculation. Let us see now with an example how we will be able to solve this frame and find the internal forces in each member. For example, AB is a beam here. Okay. Right. This AB is a beam, and you need bending moment and shear force in this one. So we will see how we calculate that, and also AH is a column. So we need bending moment, shear force, and axial load in this column. So likewise, you have so many beams and so many columns in this frame, and you are able to solve this frame with no difficulty at all using this portal method with just two simple assumptions. Okay. Right. So if you observe the given problem, which is one of the university questions in 2016, appeared in 2016, the same is taken here. So the first bay is 6 meters, then middle bay is 4 meters, and the right one is 8 meters, and the column heights, nothing but story heights are same, 4 meters, 4 meters, and 4 meters story heights. So it's a three-storied, three-bay frame. So first bay is 6 meters, middle bay 4 meters, and the right one 8 meters. So bays are different in lengths, whereas story heights are same. So to solve this frame applied by the lateral loads, you see at each floor level you have some load acting in the lateral direction, horizontal, that's nothing but horizontal loads. So you may have load at each floor, or you may not have load at each floor. Okay. So in this case, it is given at each floor. Okay. So whatever may be the variation given in either loads or the height of stories or the spans, whatever it may be, we are able to solve if we just follow the procedure that is being discussed in the earlier session. Okay. So let's see step one first. So immediately you take a problem, you apply the assumptions first. Okay, according to that particular method. So you have two methods in this uh, uh, laterally loaded framed analysis. So either portal or cantilever. So they have their own assumptions based on the methods. So we are now taken portal method. So portal method has got two assumptions. So first assumption is same for both the methods. That is, each member consists of the point of contraflexure at the middle that you are now looking at now. Say each member, you put an internal hinge, imaginary. This is just an imaginary hinge. So the Albert Smith assumed that each member will have zero bending moment in the middle. This is what is the assumption. Okay. So likewise, you have got all the hinges, imaginary hinges shown here, and anyhow the bottom of the story is fixed, right? So typical support condition at the base of the frame is fixity. Okay, so this is the first assumption. Okay, so take the given frame, see, present it in the same way as I am doing now. First, now you have a given problem, you redraw the same again, and then don't no just skip drawing the frame number of times. So as many diagrams you know draw, uh, the clarity in presentation is much bigger, right? So this is where I have taken and drawn the same frame what is given in the question, then applied assumption 1 first. Okay, right? Now let us see assumption 2 to apply now. Okay, got it? So that was the first assumption. Now let us see. So applying second assumption means what? You are calculating column shear as a step 1 calculation. Okay, so it is to calculate column shear, because what uh, the assumption is itself relating the column shears. Okay, so what it said, you consider a section in the middle of each story and apply equilibrium equation. Nothing but sum of all horizontal forces is equal to 0. Okay, so first what you do, you take a section in the middle of the top story. So this is say for example uh, top story middle, you just pass a section here. Okay, like this. So means what, you cut the frame, you just cut it uh, at middle of the top story. This is what that it means. Okay, so what is now, the entire frame has become two parts. Okay, below the section one portion and above the section another portion. So you take that part and redraw it again. That is given in the diagram here. So this is the free body diagram of the upper part above this section. Take the portion above the section. So what I have done, considered a section in the middle of the top story. Here I have taken the top story. You have to do it for each story. This is taken for top story, and apply equilibrium equation. Then once you say it is a free body diagram, you should apply all internal reactions at the cut portion. So what you have done, you see, you have cut the column, right? This, you have cut this column, you have cut this column, and you have cut this column, this one. So you have cut all four columns. So column has got now three internal forces. Got it. So what are they? Shear, bending, axial load. So this point where you have cut the frame, you had a hinge there, right? So there is no bending moment there. Bending moment is zero. There is a horizontal reaction, and you have vertical reaction also here. But what you are applying here, sum of all horizontal forces equal to zero. So though you mention it or don't mention, doesn't matter. So that's why I am not mentioning this, though it is there. The vertical reaction is there, but uh, at this point it is not required for us to show it in the diagram. Same way for all the columns presented here. Okay, right? So let us now apply the notation for horizontal reaction. That means column shear. What do you call this? Column shear. Column. So it is a column shear, right? So as this is the third story, I have mentioned column shear as P3. Okay. So what it says, now you apply assumption 2. So exterior columns, the force is P3. So for interior columns, it becomes 2 times P3. So it should be very clearly observed here that we have applied the assumption 2. So if the exterior column shear is say 10 newtons, the column shear in interior column should be twice 20. Okay, the same is done here. So there are two interior columns and two exterior columns. Okay, there are two interior columns and two exterior columns. So now you apply sum of all horizontal forces equal to 0. So all four columns you add P3 to P3 and 2P3 plus P3 is equal to 60. Or else you first write an equation form, all forces acting towards left are positive, and then maybe acting towards right negative, means minus 60 is equal to 0. The next step you have this equation. So it is 6 times P3 is equal to 60. Then the P3 value is 10. Okay. So first what we have done, we have applied assumption 1. So you have got all midpoints of the members. A hinge, you represented a hinge, imaginary hinge. Okay. Then we start applying now second assumption, which is very particular. So second assumption says the shear in interior column is twice that of the shear in exterior column. So we have taken the frame and then we have taken the top story. The middle of the top story, you cut the section. So above that section portion, you redraw it. Okay. So if you redraw, whatever you see above that section, you draw there. So what you have, the internal forces. Now, when you draw free body diagram, what you do? Wherever you have made a separation, you show the internal reactions. So column has got 3 internal reactions: bending moment, shear, axial load. Bending moment anyhow is 0 because you have cut the frame at the middle. So midpoint there is no bending moment. So no need of showing bending moment. Anyhow, even if it is present, doesn't matter because you are applying only sigma fx 0. So only horizontal forces are important for us. So at each cut portion, so you have cut this column here. So that's why I have mentioned reaction. Same way here, I have mentioned a reaction wherever the column is cut. Okay, so the four columns, and so I have applied the assumption to that the interior column shear value is double when compared to exterior column shear. So I have assumed exterior column shear as P3. P is a force, and 3 denotes the top story, third story, story 1, 2, 3. So numbering started from bottom story, and then middle story 2, then top story 3. So P3, and this is now 2 times, and then 2 times here. So if you see, the calculation part is much simple even without just calculator. With your just now manually you can perform this calculation in a simple way. Okay, so top story columns have got shear force value 10 exterior, 20 interior. That you should always know, have an idea. So force P3, nothing but what? P3 means what? Exterior column shear values are 10 and interior column shears are 20. See that simple it is. So top 4 columns in the top story has got shear force values 10 and 20. 10 exterior, 20 interior. Okay, this is for the top story. Let's proceed for the next one. So cut a section in the next below story, which immediately below story. So draw whatever you see above. Okay, so this is what is there. So you have now get two horizontal forces, right? So because you have taken a section in the middle story, so immediately above that you have a shear force, and at the top you have shear force. Okay, so now the notation you see P2. Reason what? It is the second story from bottom 1 to 3. Okay, so interior columns again, it is 2 times P2. This is from the assumption. So assumption here that the exterior columns shear, if it is P2, interior column shear will be double. Same exterior column, if it is P2, the shear value, interior column shear is double than that. Okay, so likewise, so exterior column shear is taken as P2, and the interior column shear will become twice that of it. Then apply sigma Fx is equal to 0. The equilibrium equation, sigma Fx is equal to 0. So 60 plus 30, total 90, acting towards right hand direction, right hand side. Then acting towards left is same 6 P2. So 90 by 6. 15 kilonewtons is the column shear in the middle story exterior columns. And then interior, if it is if you take the columns, it is double 15 to it will become double to 15. So 30 kilonewtons is the column shear in the internal columns. Okay, so these two columns will have 30 kilonewton shear. Then these two columns will have 15 kilonewton shear force. You can see how simple this calculation is, right? So only thing what you need to follow is just the procedure. That's it. Okay, whatever is told in the procedure, just follow it, and you can easily solve this problem. Okay, so step 1 calculation we are doing now to find shear force in all the columns. Okay, so you have now 12 columns here, top story 4 columns, middle story 4 columns, and bottom story 4 columns. Total you will get 12 values. Among that 12 values, so exterior column shears are same, interior column shears are same. So each story you have two values. So there are three stories, 3 to 6 values you will have. Though there are 12 columns, you will have only 6 values, because exterior column values are same and interior column values are same. So right, so middle story exterior column shear is 15 and interior column shear is 30 kilonewton. Whereas if you see this, this is 10, shear force is 10 here, whereas for this column is shear force is 20, right? So now the shear force increased by 5 kilonewtons here, 15, whereas increased by 10 kilonewtons here, it is 30. Likewise, it is same for this and same as this one. Okay, and this is same as this one. Right. So going for the next story, bottommost one. So first story column shear, same procedure. You cut a section in the middle of the first story, draw whatever is there from that section, take the portion above that section, so which will have all three horizontal forces applied will come into picture now. And then because we are in the first story, I take the notation P1, then apply the assumption 2 that interior column shear will become 2P1. Now if you don't have that assumption, what you will have, you see, this will become P11 column 1, right? This will become P12 column 2. This will become P13, P14, four unknowns, right? So because of the assumption, you have just one unknown in this equation. So single equation, single unknown. That's the beauty of this assumption. So applying that assumption, so interior columns will have 2 times the shear than this one. So applying that equation again, sum of horizontal forces equal to 0. Okay. So external force applied is 120 kilonewton. Again, same 6 times P1 is equal to 120. So 20 is the shear force value in this exterior column. Double is 40 interior column shear. Same here, and it is again 20 here. Okay, so 20 and 20 exterior columns and 40 in the interior column. So you can see that the shear force values are 10, then 15 here, then 20. Likewise 20 here, then 30, 40. So remaining two columns, it is same as this exterior here to the exterior and interior column to interior, right? So as I said, there are 6 values, you see, 3 and 3, total 6 values you have, but there are 12 columns. Okay, so right, so draw the diagram without thinking that there is a time waste. So draw each and every diagram carefully and then follow the procedure. The calculation is much simple. Now represent everything in a single diagram. This is step 1 answer. Okay, you have 5 steps to follow. This is the step 1 answer. You can see, right? So you have cut a section in the middle of this story. you have cut a section in the middle of this story. Then you have solved for the portion above that. Okay, so that's why you have got this arrow towards left. Okay, because the force is rightward here. If you are given for 60 kilonewtons is like this, you will have this 10 in this direction. So always be careful with the sign convention I told. So sign conventions must be very carefully seen when you follow this solution. Okay. So for this particular load given there, this is the given sign convention. So what happens in the below portion? So you have separated the column in the middle. Okay. So you have got a shear force towards left some value, say 10. So for equilibrium, you should have the bottom portion 10 like this. Okay. So now if you join these two, you don't see anything, right? That is what the free body diagram concept. When you have all the parts connected, you don't see any internal force. Once you separate them, you can see the internal force. That's a free body diagram. Okay, so that's why you have got the two arrows at each column section. Okay, what is mentioned there? Okay, so 10, 20, 20 and 10. Same here, 15, 30, 30 and 15. So bottommost story 20, 40, 40, 20. So don't forget to mention the correct notation and then the value. Okay, so this is a step 1 answer. Okay, so what do you do is, mm, first you have taken a problem, then you have solved it. So what you do is, maybe half of the page you draw this diagram empty, then keep it there for posting all the step 1, step 2, step 3, step 4, step 5 answers onto that diagram. Just one empty frame, you draw the frame with the given loads, all these loads. Okay, just 60, 30, 30. Likewise the spans and all, and then notations. So A, B, C, D likewise. So keep these and uh, keep an empty frame. uh, for half of the page you draw a big one, so that if you post all 5 steps answers into that diagram, it won't be any clumsy. Okay, so if you have a big diagram, then posting the values will be very easy for you. Okay, so we will be posting all the values onto that diagram. Okay, so as I have now in a presentation mode, I can have different diagrams, but at the end now you will have one final diagram that you should have when you are answering in the initial itself, because you don't know how much length you are going to take to draw it at the end. So that's why I'm suggesting you to have it in the initial point of time itself. So once you take the problem, then draw one empty frame without answer, put it there for half of the page or so, then proceed for the solution. Once you get say finished step 1, you post the step 1 answer, then finished step 2 answer into the same diagram. Likewise you will see that how I do it. Okay, the same you are going to do. So I have full answer which is posted to the diagram at the end, but you will have it in the initial point of time. Okay, that's a change. Just for the mm, for the sake of posting the answer onto the diagram. in a convenient way. That's all. Okay. So this is step 1 calculation. I'll stop it here. We will see step 2 and then further steps in the next session. Right. Thank you so much.